Section 6.2 Interactive Assignment Objective 4. We're going to use n is equal to 6 and p is equal to 0.75 to complete parts A through D below. So we're going to construct a binomial probability distribution with the given parameters. So in order to do that, we're going to have the following. So for each individual value for x, it's considered exactly 0, exactly 1, exactly 2, and so on. So if we wanted to use our calculator, we would do the following. And I'm going to show you the first one of how to use your calculator. So what we would do is we're going to say 6 combination 0. So 6, and then we're going to go to math, scroll to the right, and then go all the way down to number 3, and then select 0. And then we have our answer 1. Okay, so we're going to take 1, and then we're going to multiply it by the probability, which is 0.75. And that is raised to the power of 0. And then we're going to multiply that by 1 minus 0.75, or we can say that 0.25. And then we're going to raise that to the power of 6 minus 0, which is 6. And you can see that we end up getting 2.44 times 10 to the negative 4, which means that, and let me show you here what I mean by that. If we take the scientific notation number, okay, so this is the same thing as saying (2.44) times 10 to the negative 4, which means we want to move this 2.44 to the left 4 times. 1, 2, 3, 4. So rounding that to 4 decimal places, we get 0.002, and that's how we get the first one. Now, we can either use the calculator to find each individual item, or we can also use Statcrunch. Well, how would we use Statcrunch? Okay. Well, we're going to go ahead and make sure we have standard. We're going to make sure that n is equal to 6. And then we're going to put in the probability of 0.75. Okay, and then individually, since it says exactly, for each individual one, that means exactly, we're going to put in the value of 0. When we put in 0, you can see that we get 0.002. Okay, and then when I put in the value of 1, then I get, rounded to 4 decimal places, you're going to see that we get 0.044, which is what we get here. And let's put in the next value, which is 2. And we get, rounding it to 4 decimal places, we get 0.0330. And then we're going to put in the value of 3 and then compute. And we get 0.1318. Put in the value of 4, and we get 0.2966. Put in the value of 5, we get, rounding it to 4 decimal places, which means we need to move that 5 to make this a 0, so that becomes 0.3560. And then put in the value of 6, and then we get 0.1780 since we're rounding that to 4 decimal places. So you can either use the formula or we can use Statcrunch to get our values. Okay. Now the next thing they want us to do, and let's go ahead and just make sure that our results are correct here. So there are our numbers. We put the probability in, and therefore there are all our probabilities. Okay. Now the next question says to compute the mean and a standard deviation of the random variable using these two formulas and what we've done in the past. So we're going to use each number and each probability to determine that. So if you recall, we're going to take x, which is 0, and multiply by the probability of 0.02, and so we get 0. Okay, and then next we're going to take the value of 1 and multiply it by its probability of 0.044 to get 0.044. Next, we're going to take 2 and multiply by its probability of 0.0330 to get 0.0660. And then we're going to take 3 and multiply by its probability to get 0.3954. 4 times its probability to get 1.1864. And then 5 times the probability to get 1.7800. And then 6 times its probability to get 1.0680. Now remember that when we want to find the mean, we need to add up this entire column. So we're going to add up all these values to get 4.5002, and rounding it to 2 decimal places gives us a mean of 4.50. Okay. And now we want to be able to find the standard deviation. So we know that the mean is 4.50. So we know that we have a new column with 4.50. And then we're going to take our data value, which is 0, and then we're going to subtract the mean, and then we're going to square it, and then multiply it by its probability to get 0.00405. Okay, and then we're going to do the same thing. We're going to take the value of 1, we're going to subtract our mean, and then square it, and then multiply by the probability to get the next value of 0.05390. And again, next data value is 2. We're going to subtract the mean and square it, multiply by the probability to get the next result. And then again, the next data value of 3, subtract the mean and square it, multiply by its probability. Again, the next data value of 4, subtract the mean and square it, multiply by its probability. Next data value of 5, subtract the mean and square it, and multiply by its probability. And then the last data value of 6, subtract the mean to square it, and then multiply by its probability. So now when we get all of these values here on the right, we're going to add them all up. So when we add up all these values, we get 1.12440. So what that means is that is the sum of that entire column, which is what we have underneath the radical sign. So in order to find a standard deviation, we're going to take this number and then take the square root of that, which gives us 1.060779291. Rounding that to 2 decimal places, we get 1.06. So we get the standard deviation of 1.06, and we get the mean of 4.50. So let's verify that. We get the mean of 4.50 and the standard deviation of 1.06. Now we need to compute the mean and standard deviation using these following formulas. So in the next part, part C, we need to determine what is n, which is 6 in our problem, and the probability is 0.75. So to find the mean, we're going to take n times p. So 6 times 0.75 gives us 4.50. And to find the standard deviation, we're going to take n multiplied by p times 1 minus p and take the square root of that. When we take all these values and multiply them together, we get 1.125. The square root of 1.125 gives us 1.06066602. And rounding that to 2 decimal places gives us 1.06. So from here, we can see that we get the following. We get the same mean and the same standard deviation. Okay, now the next thing we want to do is we want to draw a graph of the probability distribution and then comment on its shape. Okay, so what we're going to do here is we first need to find the ordered pairs. So what we can do is we can go ahead and first put this into our Statcrunch. So I'm going to go ahead and open up Statcrunch. Okay. And then what I'm going to do is I'm going to create the value of x, which is our first column, and then our next column is the probability of that x. So we have 0, 1, 2, 3, 4, 5, and then 6. And then what is the probability of each? 0.002. Oops. Okay, make sure that's 0, 0.0002. And then 0.0044, 0.0330, 0.1318, 0.2966, 0.3560, and 0.1780. 8. So now if we want to graph this, we're going to have to go to calculators, and then we're going to go to binomial. And so we're going to have to put in what we have for our probability. We know that n is equal to 6. Okay. We know that our probability is 0.75. And we want to make sure it's going to be less than or equal to 6. So now when we compute this, we can see what our graph looks like. So I'm going to go ahead and then I'm going to copy this. So we can compare it to what we have on our graph that we have here. Okay. So again, if we wanted to graph this, then we would then plot our points. We would say that our first point here represents here, if you look at our graph, okay, let me kind of scroll this just a little bit more here. Okay, now if we look at our graph, we can see that this one matches with this, which is 0.0002. And then the same thing with 1. And then let me go ahead and expand that a little bit so that we can make sure that this matches a little bit there. Okay, so you can see here that the ordered pairs are matching each particular graph. Okay, so when we look at our answers here, which one does it represent? Well, it looks like it's this one here, B, which represents our graph. Okay, and then what we want to do is we want to determine, okay, what kind of a shape of the graph is it? Okay, so if we take a look at the shape of the graph, okay, we can see that when we draw our bell curve, okay, we can see that it's going to be skewed left. Okay, so therefore it's going to be skewed left.